Today we're going to start to learn how to solve quadratic equations, and this will be a progressive topic where we're going to start today just with two methods, by graphing and by square roots, and we'll move on to more advanced topics as the weeks progress. So a little bit of vocab that you need to be comfortable with. A quadratic equation, it can be written in standard form, ax squared plus bx plus c equals 0. So you're comfortable with y equals ax squared plus bx plus c as the way we write our quadratic equations. If we replace that y with 0, that's how they consider in standard form. Okay. The x-intercepts of an equation occur when y equals 0, and you know that from before. Always whenever we're crossing the x-axis, no matter where that point is, the y value is always going to be 0. So, because of that, the solutions of a quadratic equation, so that's going to be the values that x gives us when y equals 0, they're called roots of the equation or zeros of the function, okay, because y always equals 0 in those places. So you may hear me say the solutions, you may hear me say the roots of the equation, you may hear me say the zeros of the function. Know that basically I'm talking about the same thing, okay? Okay, so the first thing I want you to learn how to do is by graphing how you can solve quadratic equations. Now you could use a graphing calculator or a hand graph. I made these ones simple enough that you could use a hand graph. So the first thing we're going to do is 2x squared equals 0. So what I'm trying to do is graph y equals 2x squared, and I'm trying to find the x-intercepts. Okay, so I might do just kind of a basic mental table, or maybe actually a physical table, but where I put in -2, -1, 0, 1, 2, and I say, hey, that's 8, and then 2, 0, 2, 8. But the general gist, so this one's going to be off the graph a little bit, because I'm going to just count it by ones. Okay, so you can kind of see this equation right here, something like this. If I'm looking for the solutions, notice I wanted my y to equal 0. So the only place where y equals 0, right here, is at the origin in this particular graph. So my solution, there would only be one solution in this case, and it would be at x equals 0. Okay? If I have another graph like this, 2x squared plus 2 equals 0, you would switch to kind of graphing the y equals 2x squared plus 2. Okay? And notice it would look exactly the same as this, but up 2 units. So I would have my graph. It would look similar to the graph before it, but it would be shifted up 2 units. Okay, and now here, this looks a little bit tricky, I think you may realize. When we're trying to find my solutions, I'm looking for values when y equals 0. And as you can see, this never, ever, ever crosses the x-axis. So there's never a case where this happens in the real number world. So we're going to call this no solution. Okay? Okay, and then we also have this kind of case sometimes, 2x squared minus 2 equals 0. Okay, so again, I would graph y equals 2x squared minus 2. And it should look a lot like this first equation, but it shifted down 2 units. So it's going to be down at -2, and here, here. Okay, going up a little. So if I'm graphing this guy, the blue one, and then I start looking for my solutions to the equation, again, I want y to equal 0. This time it happens multiple times, okay? 2 times that y is equaling 0. So it looks like x could either equal -1 or +1 in this case. And you could write that as plus or minus 1 if you want. You could write the solutions at -1 or 1, -1 or -1, 1. So this one has 2 solutions. So I want you to kind of think about this. If a graph is going, let me make a new page. If I have a graph and it looks like this, how many solutions does it have? Okay. If it looks like this, how many solutions does it have? If it looks like This, how many solutions does it have? Okay, so I want you to be thinking about what types of graphs would have no solution, two solutions, one solution. Okay, and it should be obvious when you look at a graph how many solutions that has. Okay, a second way that we like to solve these, and this works for some really nice, basic, simple quadratic equations, sometimes we can just solve them by using square roots. Okay, so if I'm saying this, 3x squared minus 75 equals 0, I'm going to try to solve this like a typical quadratic, or just like a typical equation. Let me pretend it was a linear equation. I'm going to try to solve it by doing the same thing to both sides. So at first I'd add 75 to both sides, and I get 3x squared equals 75. I divide by 3. Okay, and I get x squared equals 25. Okay, if I'm taking the square root, or head to squaring something like x squared to get 25, there's a couple ways to think about it. One thing is you may want to take the square root of both sides. The tricky thing to note is that the square root of x squared, it equals the absolute value of x. For example, if x equaled -6, and I said something like this, x squared would be 36, and I said, hey, what's the square root of 36? You would tell me 6. It would be the absolute value of that -6. So if I square root both sides here, we're going to say that the absolute value of x equals 5. In other words, x equals plus or minus 5. Okay, a lot of people really forget about that second one. If you don't like thinking about it in absolute value terms, I will allow you to just kind of logic it out. If x squared equals 25, then x must either equal positive or -5. But it's good for you to get practice with this definition here, the square root of x squared equals the absolute value of x, because it will come up over and over again. So let's try this one. 5x squared plus 15 equals 15. So in a solution like this, or in an equation like this, I would start by subtracting 15 to both sides again. And then I get 5x squared equals 0. Divide both sides by 5. And I get x squared equals 0. Okay. If I take the square root of both sides here, I get absolute value of x equals 0. But there's only one number that has an absolute value of 0, and that is 0. So this equation, it only has one solution, whereas my first equation had two solutions. Okay, I'll give you something like this. 8x squared plus 32 equals 0. Okay, again, so we'd have 8x squared plus 32 equals 0. I'm going to be subtracting 32 from both sides, and I would have 8x squared equals -32. I divide by 8. Okay, and I get x squared equals -4. Okay, if I wanted to square root both sides there, you're going to notice I'm going to be getting into some problems. Because when I try to take the square root of -4, oh, it does not have a real number solution. So this is an equation that has no solution. Okay, and I like you to kind of think about this. If you had just pictured what this graph looks like, that y-intercept would be at 32, and that's also the vertex here, and it would be opening up. So I think it's kind of obvious to see that it's never going to cross the y-axis, and it's going to have no solution. Okay, so let's do a word problem. A museum is planning an exhibit that will contain a large globe. The surface area of the globe will be 315 square feet. Find the radius of the sphere producing the surface area. Okay, use the equation surface area equals 4 pi r squared. S is the surface area and r is the radius. So we know that the surface area is 315, so we're going to plug that in for s. So 315 equals 4 pi r squared. Okay, I'm trying to get r alone. I'm going to divide both sides by 4 pi. Just because I saw a lot of my math counts kids doing this, I want to make sure you can do it right. So if I am actually going to divide by 4 pi, I need to make sure that I put that 4 pi in parentheses. So I'm going to do 315 divided by parentheses 4 pi, close parentheses. Okay, so I got a value that I'm looking for. Okay.
For an interruption, Wendy Bonson, please.
All right, so when I've done something like that, it looks like that about 25.066, I'm trying to recall, right? That's about r squared, okay? So if I take the square root of both sides here, the easiest way to do this on a graphing calculator is to go put in your square root symbol like you usually do, and then so it doesn't have to round. Oh, obviously I rounded wrong to 0.0669. I'll throw that in later. Just go to this above the negative sign. It says ANS, answer. Square root of answer. But you have to remember to hit second. It's not going to work. So second answer, and then hit enter. And it gives you an approximate square root, about 5.007. Okay. And I want you to think about, do you need the negative square root this time? Okay, 5.007. I don't think we need our negative square root. The reason being, it's a radius of a sphere, so it does not need to be negative. This is in feet, so we're going to call the radius about 5.007 feet, or about 5 feet. Okay. All right, what I really want you to be comfortable doing is being able to know how many solutions a quadratic equation can have. Okay, so all the possibilities, and also how can you determine the number of solutions by looking at the graph. Okay, so I want you to be really comfortable with those two things before you come into class tomorrow, and I'll see you soon.